Publishing Part 2, Server Publishing and H323 Gatekeepers. In the first ISA publishing nugget that we talked about, we went through the foundations of what server publishing was all about. What is this concept? And then we also talked about how to make web servers available to the outside. There is so much to web servers that we kind of broke that off into a separate section. Now in this second part of the publishing nuggets, we're going to focus in on the rest of it, the missing pieces. First off, we're going to talk about server publishing. Not just web servers. I'm talking all the servers that are available out there, because ISA server lets you publish anything that uses a protocol, which pretty much encompasses everything. We're going to pay special attention to our mail servers. One of the main servers that people make available is SMTP servers. There is actually a wizard in the ISA server that allows you to publish a mail server, and we're going to look at that one, and then we'll turn our attention to the rest of them, all the other servers that you might want to make available. In the second part of this lesson, we'll take a look at the Spam Blocking 101, the message screener. Here's the concept. You can actually screen the messages as they come into the ISA server. I mean, before they even hit your internal email server, you can make sure that they don't include certain keywords and certain sender names, certain receiver names, that sort of thing. I know we talked about how some of this stuff is done earlier in one of the previous nuggets, but overall in this section I'm going to tell you how to set it up, how to set up the message screener service so that it can catch those incoming emails. In the second part of this nugget, we're going to take a look at the H323 gatekeepers. And really, I've broken this down into two separate sections as well. First off, what is H323 all about? When most people think of H323, instantly a certain application pops into their mind. That application? NetMeeting. I can do video conferences and audio conferences and that sort of thing. But H323 is much bigger than that. I want to give you a vision of where H323 is going. Second off, I'm going to show you how the gatekeeper fits into that whole scheme. It's actually part of the H323 protocol definition and some of the standards that were developed. So Microsoft supports a concept called an H323 gatekeeper. I'll tell you what that's all about. Well, let's start everything off with the server publishing. Server publishing in 4 easy steps. Well, maybe 4.5. Because what we have at the beginning is this optional step of creating a protocol definition. Server publishing makes an internal server available to the outside world. So you may need to create a protocol definition that defines what protocols can be used to access that server. Now, ISA server has many built-in protocol definitions, but if any of those don't fit, you can create your own. So in the real steps, step 1, you're going to name the rule. Nice logical name. 2, map the internal to the external address, so you know which server can be reached based on the address accessed. From there, choose your protocol, and you see the optional above. Which protocol would you like to access that internal server? And then finally, select the clients. What clients do you want to be able to reach that internal server? Do you want everybody, a specific group, only certain users? What do you want for the client base? So let's go ahead and do this on the live ISA server. But before we do, let me define just a little scenario. We've got our ISA, right? It's connected out to the internet. And then over here, we're going to have on the internal LAN, we'll just do a basic publishing here. We'll have, let's make it SQL, a SQL server, because there is an actual SQL protocol that you can use to access that. Let's do this step by step in the live ISA interface. First things first, let's go ahead and expand the ISA Management Console and check out our protocol definitions. These are the protocols that are going to be able to access the ISA server. It's under the policy elements and was typically used in the previous nuggets to supply what protocols would be used for outbound access. When you click on this, you look at the list and go, holy cow, sweet mother of protocols. There's tons of them here. And sure enough, there are. There are many protocols out of the box that ISA server supports. Now, when we get into the server publishing wizard, you're going to only see a subset of these. And you might think, well, wow, ISA server must only allow certain protocols to be published. Well, here's a tip. The protocols that will show up in the server publishing list are the protocols that have been defined as a primary access direction of inbound. Many of those protocols that you see in that list over here on the right-hand side are defined for outbound access. If they are defined in the direction of inbound, that would be a potential to be used as a server publishing protocol. So our mission, as I showed you in the diagram before, was to publish a SQL server. So I'm going to go to this publishing area, expand it, and click on the server publishing rules. As of right now, there's none. And you remember, this is the same place that we went to publish the internal web server. This time we're going to the straight server publishing rules. I'm going to click on New Rule. Now above it, notice, I just want you to notice for now because we'll come back to it later, it does have a specific area to go to for publishing a secure mail server. More on that in a few. I'll hit New Rule and we'll name this one SQL Server. Nope, let me click on that box. Enter. Now it's going to say, what is the IP address of the internal server? Now one of the nice things it has is this find option. So if you know the server name, for instance, my internal SQL server is just called server. I can hit find, and instantly it goes, oh, that's 192.168.1.100. Sure enough, hit enter. Browse for the external address, and pretty much I'm matching right now an external IP address to an internal IP address. Which external one will reach what internal one? Now this is where we get to choose the protocol. What protocol do we want to allow access to? I scroll down and there's the one I was looking for, Microsoft SQL Server. That's a built-in protocol definition for the SQL Server for inbound access. Notice also in this list all of these server-based protocols. One of the keys that you'll find is when you're looking at the protocol definitions, all the inbound access have the keyword server right behind it. I'll choose SQL, hit next. Now I get to say, what do I want to apply the request to? If I want, I can filter those incoming requests based on a specific client address set, or I can just allow anybody to access it. Cool idea here. If you have that two-tiered firewall design, and maybe you only allow specific DMZ servers to access your internal SQL server behind the second firewall, this would be a good idea to say, well, only the Exchange box or only the web server box can access this. And that ensures if there's any sort of network compromise that only a single or a few IP addresses can get in. But for now, we'll just say any request. From there, it says you're done. You've finished the new server publishing rule wizard. I hit finish and I now see the SQL Server rule show up in the list, and I'm now going to have a mapping from that external address using the port numbers that SQL use to the internal SQL Server address. Using the process you just saw, you can publish any rule for any protocol for internal servers on your internal network. You can create incoming rules for just about anything. But for now, let's go ahead and turn our attention to the Secure Mail Server Publishing Wizard. This is a wizard that allows you to make your internal mail servers available to the public. And overall, when I hit next here, you'll be able to see that we can choose all of the protocols that we would like to make available through the ISA server to the internal mail exchange server or whatever mail server you're using on your internal network. Now the question I commonly get when I open this is, well, wait a sec, couldn't I just go out and manually create these rules? I mean, incoming and outgoing SMTP, POP3, news protocol, the network news transfer protocol. Overall, all these rules could be created manually. But then I might ask, why do it that way? Why do it the hard way? That's why Microsoft created this wizard, was to make all of the common exchange protocols, all the common mail protocols, I should say, available from one single wizard, and it'll set it up for you all at once. Now you have the selection here. Do you want to use default authentication or SSL authentication? For every single checkbox you choose, it's going to create a separate rule. Now, keep in mind, if you use default authentication, it will allow the authentication credentials to pass through in clear text. So if you're using a certificate-based SSL authentication, it is much more secure. Now, a word on this protocol right here. Why did I not check the incoming Microsoft Exchange Outlook protocol? Well, overall, let me explain what it is first. This protocol allows external Outlook clients to connect to your internal Exchange server. So let's say you were sitting out on the internet somewhere. You could open Outlook, type in the external IP address of my ISA server here, and boom, you would go through and connect to the internal Exchange server. It's quite handy. However, when you make this available, it pretty much opens up all the NetBIOS and RPC port numbers. for the Microsoft Exchange server, and there has been a lot of security attacks on the RPC and NetBIOS services on Exchange. So my best recommendation for you would be to make your external clients VPN into your network first, then connect to the Exchange server using Outlook. If you have the VPN tunnel created, it solves that problem of security. So this is usually not a good idea for external users. We'll also talk a little bit more about this content filtering in just a few. That's a major feature that ISOServer provides. But for now, I'll click Next. It's going to say, what is the external IP address of the ISOServer that you'd like to make available for the Exchange server or the mail server inside? And I'll choose the only external interface we have. Hit Next. We'll say, again, we're going to use the internal name of server. That's our mail server on our inside network. I'll hit Find, and it defines it as 1.100. Click OK. And by the way, you can also host an Exchange server with the ISOServer running on it. By that point, though, your processor and memory utilization have got to be pretty high. It's usually not recommended to put Exchange or, well, any service that you can on the ISOServer because it's supposed to be a dedicated firewall. And the more services you add, the more potential security holes you have on your firewall server. So I'll click Next. It's going to say, I'm finished. When I click on Finish, you'll see all of these different rules appear in the list. It shows the published IP address for every single rule. And again, IMAP4, IMAP-S, NNTP, NNTPS is based on security. You can see one of these is the default authentication. That's the one without the S. And the S means that there's the SSL certificate being used. It then shows over here what address mappings we have between each one of them. And again, we can filter based on the client that is accessing the server. Here's a tip. When you ran that wizard, it never asked you, hey, do you want to make this available to only a certain list of client address sets, certain domain names, certain ranges of IP address? But you can go back in. You can say, okay, now that I'm done with the wizard, maybe I only want certain clients to access this server using POP3. That's when I can come up here into this Apply to Client Address Sets specified below. So you can come back in. Even though the wizard didn't do it, you can come back in and manually add the specific client address sets that you want to access your Exchange server. That might be a way that you can make that publishing of the Microsoft Exchange/Outlook protocol a little bit more secure if you need to make that available on the public network. Now, before we leave the mail server behind, there's a common question that many people have asked me. That whole mail publishing rule, does that work for Outlook Web Access? For those of you that haven't heard of it, Outlook Web Access is a fairly new feature of Outlook that allows people to retrieve their email from a web-based interface. And it's awesome. I'll tell you what, I just saw the new interface for Exchange 2003 Outlook Web Access. Phenomenal stuff. So let me show you. By the way, that the secure mail wizard doesn't create rules for Outlook Web Access. So let me show you how to make Outlook Web Access available in the most secure format that you can. The first thing that I would do is I would go to this destination set and create a new one. And we might name it for Outlook Web Access, we'll use OWA. From here, we get to choose what destinations people can access for Outlook Web Access. Now remember, this is on our internal Exchange server. So let's say that our Exchange server is going to be running at the name exchange.local.com. From there, I'm going to specify, and let me go ahead and copy this because I'll use this a few times. I'm going to specify specific directories that people can access. The first one is going to be Exchange /star because that's one of the major virtual directories available for Outlook Web Access. I'll go ahead and paste this in again. And the other major one is going to be EXCH web star. One more, I'll hit add, and it will be /public. Once you add these three directories, click OK, you've now made Outlook Web Access available to the external world. Well, we've created the destination set to do so, but hang on, we're not done. We need to create a web publishing rule. We'll hit New Rule. Again, I'll name it OWA. Apply the rule to a specified destination set. Which one do you think I'm going to use? You got it, Outlook Web Access. So I'm creating a web publishing rule. Why? Because Outlook Web Access is a web interface. Hit Next. I can specify what client types I want to access that and filter it down if necessary. For now, I'll just go ahead and say any client, and then I will direct them to the IP address of my internal Exchange server. I'm done. I'll hit Next and Finish. I have now made Outlook Web Access available to the outside world. That is a way that you can make the most secure configuration for Outlook Web Access happen, because now they can't access your whole Exchange server, only those virtual directories you've specified. The final topic dealing with email servers is going to be the message screener. Now, back in the firewall nugget, I talked about an application filter called the SMTP filter. And it allows you to configure a lot of the filtering options. So you could filter based on keyword in an email or your users and domains. But I also mentioned in that nugget, there's more to this than meets the eye. Get into the future nuggets in the publishing world to discover what that is. Well, here is what that is. It is the message screener service. When you install the ISA server, one of the options that you can select right above the H323 Gatekeeper is the message screener service. It's truly this screener that allows you to filter on any of these criteria. The reason why is in order to filter on some of these, like keywords, it has to open the email and look at it to find out what it contains. Now, in order to do that, you need a few of the following things. Well, actually all of them. First off, you have to have that ISA application SMTP filter configured and active. That's the one we talked about in the firewall nugget. You have to have all this set up, what filtering criteria you're going to use. Now, here's what we didn't talk about. The first thing that you need here is a server running Internet Information Services 5.0 or later that has the SMTP service running and the message screener installed. Here's the idea. The IIS server that comes with Windows 2000, Windows 2003 has this SMTP service that comes with it. Now that service is what allows the ISA server or some other server in your network to open the email and look at it so it can figure out what kind of keywords it can filter on. Now, there's many different strategies that you can use. You can install IIS on the ISA server and include SMTP on there. You can install IIS on some other server inside your network and include SMTP in there. Or you can install IIS on your Exchange server and share that burden and have the SMTP service running on there. Now notice it also says, and the message screener installed. You can actually do a partial installation of ISA server and only choose that custom message screener option. You don't have to install the whole thing, so you can throw that message screener on any server in your network. You might do that to share the load. My recommendation is that you only install this on either the ISA server itself if you don't have too much email, or have a dedicated server somewhere in your network running IIS that hosts this. Finally, the last requirement, of course, is you have an internal mail server, the real mail server, that will receive the emails once they pass this filter. Let me show you this configuration on the ISA server. You can see that I've opened the Internet Information Services Manager on the bottom of my taskbar on my ISA server. Now, I've installed the SMTP service in this instance of IIS. Now, this is the IIS on Windows 2003. It looks very similar to Windows 2000, except it's called Internet Services Manager in Windows 2000. Either way, I have SMTP services running on this server. And before I get into the configuration, I want to let you know that I do have this running, IIS and the SMTP service, on the ISA server. This is just one strategy. You could have this running on a separate internal server or the Exchange server itself. I'm going to set it up on the ISA server, and it's pretty much a similar system for whatever configuration you use. We just distribute the functions instead of having them all in one place. I'm going to go to the properties for the SMTP service itself. And the first thing I'm going to change is which IP address it receives incoming emails on. As of right now, it will accept anything on both IP addresses, external and internal alike. I'm going to choose the internal. Why? Because I'm going to publish the service through the ISA server publishing to point to this internal IP address instead of my internal Exchange server. You'll see that in just a moment. The next thing I need to do is I need to configure the domains that I want to receive email for. I'll go ahead and right-click on domains, hit New, Domain, and you can choose either the remote domains or an alias of a domain. We'll choose a full remote one. And I'll select that I want to receive email for local.com or whatever domains you are receiving mail for at your company. You'll need to specify all the domains right here that you will accept to receive mail directed for. Now I'm going to go to the properties for local.com and select this forward all remote mail to smart host. What is a smart host? It's your internal mail server. And note that the syntax has to have the brackets around it, or I should say the IP address, has to have this right and left brackets sitting around it in order to be accepted. That's just the format you type it in for smart host. I'll click OK, and I am now done with the SMTP portion on my ISA server. Now I can get into the ISA management console itself and start configuring my policies or my publishing system to publish that internal IP address. So let's expand the ISA server, come down here into my publishing area, and I'm going to create a new publishing rule. Now, here, stop right here. You'll notice that I've removed all of the rules that were generated by that Secure Mail Publishing wizard just a moment ago. We're going to do things a little bit differently now. I'm going to go to New Rule. I'm manually creating one for incoming SMTP. Okay, my mail that will be received by the ISA server. Now, I deleted all of them, but we could have left all of the rules except for that incoming SMTP rule, which forwarded it directly to the Exchange server. Why? Because instead of going directly to the Exchange server, I'm now going to 192.168.1.14, which is the internal IP address of the ISA server. Now, what is the external one? I'll just let the wizard fill that one in for me. That's the external IP address that will be received on. So here's the thing. Instead of forwarding emails that are received on the external interface to the internal Exchange server, we're going to forward those to the internal interface of our ISA server. Why? Well, let me go ahead and select SMTP as my protocol, and we'll say any client request is fine. Now that I've created this rule, when it receives them, it will go to the internal interface. Let me answer that question. Why? Because as soon as it forwards it to 192.168.1.14, Internet Information Server's SMTP service will pick it up, check if it's for local.com, which is then caught by the message screener service. Phew, this is a tangled web. The message screener service that's installed on this ISA server. It will forward it to the application filter of SMTP that we defined back into the firewall chapter that will look for the keywords of, in this case, credit card. We defined this earlier. The V1 GRA is the rejected senders and rejected domains of Hotmail. We set all this up earlier to look for specific criteria in the email. The last thing I got to do is enable that SMTP service. It will want to restart our service to make that work. Now it will be filtering all those SMTP emails before it forwards it on to the internal Exchange server. Now note that I do have the message screener service installed on this ISA server. We installed it way back in the first nugget when we talked about ISA server installation. But this is now allowing the ISA server to filter those incoming emails. Before we leave server publishing and get into the H323 Gatekeeper, let me give you my rules of thumb that I've created for server publishing. First thing is that you can only publish a server once per external interface, one time. For instance, if you have an external interface of 130.1.1.1 and you want to make a web server available, you can only do it on port 80 once per external interface, because if you have two web servers going to the same port 80, ISA server isn't going to be able to tell the difference as to which one they're requesting when an incoming request is received. The second rule of thumb is that generic server publishing does not allow you to redirect ports. I know with that web publishing wizard, you could go through and redirect port 80 to some other port, or the HTTPS redirected to some other port. Well, generic server publishing doesn't support that. So by publishing a web server through generic server publishing, you're losing the ability to do port redirection on your internal network. Third piece is that ISOServer does not support true address binding. Here's what I mean. You can make a service available through the ISOServer. I can say, I want port 25 incoming on the external interface to go to port 25 on the internal network. However, it does not support true address binding, saying all requests on that external address goes to this internal server. It doesn't support mapping, literally, an external IP address to an internal IP address. It only supports mapping specific port numbers. Finally, some of you may be tempted after you see how easy server publishing is through the Server Publishing Wizard to publish a web server using that same method. Well, when you do that, you lose a few features. Publishing a web server through server publishing causes a loss of, number one, the caching features, because server publishing does not do caching of web pages or FTP content. And you also lose this port redirection feature that web publishing gives you. So web publishing, the reason they made that wizard separate is it does give you a few more features than the generic server publishing wizard does. Now let me turn to a topic that I am truly passionate about, and it is the world of H323. The first thing that we're going to talk about is what H323 is all about. And forgive me in that little subsection, because as I mentioned, I am really excited about where this is going in the world of IP telephony. Oh, I'll stop there. We'll get into that in just a moment. The second thing we'll talk about is how the gatekeeper fits in, because ISOServer has the ability to run an H323 gatekeeper. So you may ask, what is it and how does it work? I'll show you that. Finally, we're going to look at how to actually configure it, how to set it up on an ISOServer and make it act as an H323 gatekeeper. Well, let's start off with the foundations. What is H323? Chances are you've probably heard of it or even used it before. But what H323 is a ITU standard that defines how audio and video connections are established across the internet and across any network type that deals with data in the world. This is how big it is. This is going to be the future of telephone systems. Here's the idea. In the world today, we currently have a separate phone system, a separate video system, and a separate data system. And you may have noticed those three are coming together. For instance, I have a DSL connection at home, and my DSL phone provider provides me my phone, internet, and cable service all through a single line. And cable companies are likewise doing the same. They're providing all three services. Eventually, you're going to see all three services merge into one network. H323 will be one of the major protocols that makes it happen. And here's why it's being defined. As of right now in the world today, we have all of these offices that build the phone networks. Many of you know that they're called COs, central offices that tie all the phone companies together. So when someone up here sitting in Minneapolis dials somebody down here sitting in California, they can communicate through that entire system because it's all based on a standard. It's actually called SS7. Signal System 7, Signal System Series 7, is defined to allow communications between all of these COs so they all speak the same language. Likewise, we now have the internet. And we're connecting computers, and truth be told, we now have phones that are connecting to the internet. And these phones and signaling systems all need to speak the same language. Guess what it is, guys? It's H323. That defines how the connections are established. So this phone, which may be a Cisco IP phone, that's the world I specialize in, and this one over here might be a Nortel IP phone. Those two could communicate if they were both based on the H323 standard. Now, it also defines how devices negotiate their capabilities. For instance, this Cisco phone may speak a language called G.711. That's a specific codec, and we'll talk about that. This Nortel phone may speak G.711 and G.729. All right? These two are going to communicate and say, oh, let's agree on common ground. G.711 will be used. Now, what is G.711 and G.729? Well, that is actually a specific audio codec. a coder-decoder. Okay? This is where I get excited because this is where the future of telephone systems becomes very efficient. Okay, here's the idea. In the typical world, a phone call, you're sitting down here, we'll say your name is John or Mary, and John down here calls Mary up here. How much bandwidth does that take? Well, if you've played with phone systems for a while, that's about 64 kilobits per second plus signaling of voice bandwidth. Here's the beauty. The audio and video codecs, and there are many of them defined for H.323, range in bandwidth consumption from G.711, which also consumes 64K, down to codecs like G.729, and this is just one of them. Guess how much? 8 kilobits per second. 8K. So what we're doing is we are actually increasing the efficiency of our voice call to take 1/8 of the bandwidth that the traditional world does. Now, many questions arise. People think, holy cow, the audio must sound horrible using 8K. I mean, it has to, right? I can't tell a difference, and I've used both of them plenty. The only time I can tell is when you play music, because this is geared for the human voice, and if you hear music across it, something just doesn't sound right about it. You can understand it, but that's what the H.323 standard defines. It's like the TCP/IP of the audio and video world, right? We all have to use TCP/IP. Well, likewise, H.323 is a whole set of standards, just like TCP/IP is, that defines how audio and video works across the internet or any data network that uses it. Now that we've defined H.323, let's turn our attention to where ISAserver fits in. The H.323 gatekeeper. What is it and how does it work? Well, I'm assuming many of you have at least heard of the new Lord of the Rings trilogy that is out there and has taken the world by storm, the latest and greatest sci-fi world. You have this ring that kind of rules them all. It gives the person great power. Well, in the world of H.323, the gatekeeper can be kind of referred to as the Lord of the WAN. As you see here, it's sitting right on that WAN cloud, just like the Lord of the WAN would. And we have 3 different locations. Now, here's what the gatekeeper does. It is the one that watches over the wide area network. Number 1, to make sure that it doesn't run out of bandwidth. For example, maybe we have one site over here with 128 kilobits per second on their WAN link. We might have this site with 500 kilobits per second on their WAN link, and this site with 256 kilobits per second. Now, the question is, what if we have all these phone calls? These are my little phones. We have phone calls going across the WAN. What if the WAN runs out of bandwidth? For example, maybe we've got some data going across here and we've got 64 kilobits per second left. Well, one phone call could consume easily that much. But what if the second phone makes a call? Does that mean that their quality will be bad? Unfortunately, no. That means everybody's quality ends up bad because the WAN will end up dropping packets. It doesn't care which conversation it drops. It'll drop both of them evenly. So both of these conversations end up crackling and sound like a bad cell phone call. The first primary function of the gatekeeper is to watch bandwidth, to make sure that it doesn't get exceeded from any one location and ensure that we have bandwidth available for every call. And if we're out of bandwidth, it will either deny the call or send it off to the public switch telephone network as a backup. The second major thing that a gatekeeper does is resolve numbers. For example, we might have at each location a specific range of numbers that are used. We might have at this lower right corner extensions 1000XX. Okay, so any number that begins with 10 and has XX, maybe there's 99 potential extensions over here. Over here we have extension 2000XXX. There's a bunch of extensions here that we can dial. And over here we have extension 3000XXX. Okay? The gatekeeper is going to keep track of all those. So when this person picks up their phone and dials 3512, it will actually head up to the gatekeeper, and the gatekeeper will say, oh yeah, that's at site 3 down in the lower left, and it will make that connection possible and resolve that number. Now the beauty about this new H.323 world and IP telephony is, guess what? We might not even use numbers. You might say, I'll pick up my phone call and type a couple buttons or drag and drop on your screen, and I want to dial an email address. Well, the gatekeeper can actually resolve email addresses to phone numbers or IP addresses at the remote site as well. So it is the lord of the WAN network and pretty much your entire H323 telephony system. Now the ISA server is the one that can run the gatekeeper service. And you might think, well, with such a huge responsibility, you might want to keep that redundant. Well, chances are you are. And each site could have a gatekeeper. And by the way, these are my little routers. Each one could run an ISA server with a gatekeeper function that allows it to resolve those numbers locally rather than relying on a single point of failure somewhere else in the world. There's a few things to know about the configuration of the H323 gatekeeper. First thing is you don't configure it from where we're used to. Under the ISA server we have all these rules, but you may have noticed it throughout the rest of the demonstrations. There's always been this H323 gatekeepers area. Now in order to be able to add your ISA server as a gatekeeper that you would like to manage, you need to make sure you install the gatekeeper option. During the installation, you choose either a full or custom installation and check that little H323 gatekeeper option because Microsoft knows not everybody is running an IP telephony network yet. So if you've added that or you've gone back and rerun the installation and just added that additional option, you'll be able to add the gatekeeper and choose either this system or another computer. Below, the ISA server box that we have added shows up. Now underneath here you have quite a few options. The first one is the active terminals. This is going to be what active users are using the gatekeeper and which ones are registered with this gatekeeper for it to route calls to. Now you can, as I right click on it, you can register a static user and make a static phone number to IP address mapping for individual users in your network. So that way, when the gatekeeper sees an incoming phone call to maybe 1234, it knows to route it to the phone address that you type in right there. That's one of the ways to do it. Now, that's the long way. Hopefully you have users using NetMeeting or some other program that can dynamically register with the ISA server. You can configure NetMeeting to come out here and say, hey, I'm available. This is my phone number and IP address, and it works similar to DHCP. You actually have the IP address mapped to a phone number now that allows it to be reached whenever it receives an incoming call for a specific user. If I move down a little bit, I see this active calls area. Now the active calls is the most straightforward item in this list. It displays any active calls that you have. There's no special options to it. Just any calls that are currently going on, it will show the to, the from, the start time, and the status of the call, whether it's on hold, off hook, what's the story. So that's a way to monitor your voice over IP network. You see how this gatekeeper is really the lord of the WAN? It's really like the PBX system, if you will, of your IP telephony network. So it's a pretty powerful setup. Now down here we have the call routing. This is where most of your action is going to happen. And this is where you can set up a complete call routing table for your IP telephony network. And this can take some time, especially if you have a big network and a lot of destinations. You see it's divided up into 4 major categories. First off is the destinations. Where can you go? Then we have the phone number and email and IP address rules that we can define on how to reach those destinations. For example, you could define a destination of a remote router and give its IP address. And you can say, if I receive a call on this phone number, send it to that remote router. Let me show you this. I'll click on Add Destination. And you see it's going to take us to this wizard that allows us to add many different types of destinations. For instance, right here we have gateway or proxy server. Let me tell you this. Cisco created a gatekeeper product for their Cisco routers that run a recent version of the iOS. That's the Internet Network Operating System. It can actually act as a gatekeeper even though it's a router. So if you maybe had one of those somewhere in your network or knew somebody that was maintaining one, you could check this. Now the Internet Locator Service is a service that's out there. You can define one, you can create one, or you can use a public ILS that resolves email addresses to IP addresses. So if you have calls going to email addresses, ILS can do the resolution. Down here we have a gatekeeper. This is maybe you have another ISA server somewhere out there on the Internet or somewhere in your network that you want to refer calls to. You can check gatekeeper and define a gatekeeper as a destination. And by far, in my opinion, the coolest one and the most potential for the future is the multicast group. Multicast allows you to send a single message to a whole group of people. And what you can do is you can define a whole bunch of gatekeepers that respond to a single multicast address. So essentially, your phone dials 555-1212. Your gatekeeper says, I don't know who that is. Let me send it to the multicast group. Boof. One message goes out, and it actually makes that noise. Boof. One message goes out. Many gatekeepers receive it, and then one of them goes, oh, I know who that is. They're right behind me. I'll resolve that to an IP address, and responds and does that resolution. So let me just go ahead and add a gateway. Let's say it's a Cisco router, so we can have a destination in here, and you can see how this works. Let's say that remote router, I'll make up an IP address. This is its IP address that it's using. From here, description, we can maybe say this is a Cisco gatekeeper. I'll hit next, and I'm done. All I've added is the destination, one single potential destination that we could have that at. Now it's up to me to define the phone number rules, the email address rules, and the IP address rules that say why use that destination. For instance, let's do a phone number. I'll hit Add Routing Rules. Next, the name we'll say is the Boston office. Maybe Boston is the one that has that Cisco gatekeeper. Okay, and I'll say in Boston, all the phone numbers begin with 78. Maybe I know they all use 78 extensions. 78, whatever. They're 4-digit extensions. Now you have this checkbox down here, and what it's saying is, do you want to route all phone numbers using this prefix, or is that an exact number? What that means is this the prefix for Boston, or is that a specific phone number at Boston, as in somebody would dial 78 to reach a certain phone? Well, as I mentioned, they use 4-digit extensions, so I know that's a prefix. I'll leave that checked so it knows any number starting with 78 will go to Boston. I'll hit next, and now it's going to say, what destination type are you going to? Do you have no destination? Is this like a whole phone number that goes nowhere? Is it going to some sort of registration database or to a gateway or proxy server? Now you can see down here there's some options grayed out, and we'll talk about those in just a moment. Since we defined a Cisco gateway, I'll choose gateway, and sure enough, the only destination that I defined under this destinations shows up here. This is how big it can get. You could have many different destinations for many different things, but in our case, we've only had the time to create one. So I think you're starting to get the picture of how much configuration can go into setting up a full IP telephony network. Now we have the option down here. Do you want to change the phone number in any way? For instance, if you send it to Boston and they dial 7801, will it be recognized when it gets to Boston? Do you want to discard a certain number of digits from that phone number, or do you want to add something? For instance, take this. You see how many for instances there are. Take this example. Let's say the WAN was overwhelmed. It doesn't have any bandwidth left, and you need to send that call across the public switch telephone network. You need to use the normal phone network as a backup. Well, if you sent 7801 to the normal phone network, what's it going to do? You have fast busy signal or something. It's not going to go through. You need to add a prefix to say, you know what, if we do go that direction, we need to add 1634555 to the front of that number for it to be a valid PSTN, Public Switch Telephone Network number. But for now, we're going directly there over the gateway, so I'll just hit next. No change. Metric. This is going to say how many hops, how efficient is this routing rule to get to Boston. The more metric counts you put here, the less preferred it is. A higher metric means it's further away and it's a less preferred route. So if you have multiple routes to get to Boston, you can put different metrics so it knows which route is preferred and which one is not. Since this is the only one we're creating, we'll just say 1, finish, and now we have added the Boston office. Essentially, we're creating a phone book. We're creating a white pages of our entire network. And what you're going to do is define all of the phone numbers, all of the email addresses, all of the IP addresses that are available across the telephone network. Things that will match to specific destinations that you define in here. So for those of you setting up an IP telephony network, you have your work cut out for you. My hat off to you, because you are going to design a phone system using the ISA server, and the gatekeeper is going to be the main piece of that. This is the manager. This is the Lord of the WAN, the core component of that H323 IP telephony network. So what have we seen in this nugget? Well, a whole lot, including how to make generic server publishing work with a special focus on the mail server publishing. We have a specific wizard to do that, and the message screener. It is complex, but you can make it work by having IIS with the SMTP service running either on your ISA server or some other internal server on your network. We wrap things up just now by talking about H323 gatekeepers and really what I think the future of IT is going to be all about. IP telephony combining voice, video, and data all into a single network. We finally talked about how ISA server uses that gatekeeper service to be the white pages for the IP telephony system. I hope this has been informative for you, and I'd like to thank you for viewing.